Hello, welcome to Chapter 1, Section 8, Introduction to Functions. The first thing we're going to learn as we learn functions is all of the vocabulary that goes with it. We're going to start with the coordinate plane. This is formed by the intersection of two perpendicular number lines. And you've worked with coordinate planes before. They have two axes. Axis, single, axes, plural. Then they're the number lines. You have the origin, which is where the number lines meet, and that is at point 0, 0. This is what a coordinate plane looks like with your number lines. This is the x-axis, and this is the y-axis. And where these axes meet is 0, 0. That's called the origin. 0, 0 is written like this. It's an ordered pair. It's two numbers formed by the x-coordinate and the y-coordinate to tell you exactly where it's found on the coordinate plane. And in order to write a correct ordered pair, you need parentheses and a comma. When you're looking at a coordinate plane, you have quadrants. It naturally makes 4 different sections, and these are labeled with Roman numerals starting in positive, positive, and working their way counterclockwise. Why they do it this way, I don't know. But counterclockwise around, so we have sections 1, 2, 3, and 4. When you go to graph on a coordinate plane, you take your ordered pairs, and you are going to go out the x and up or down the y. This is the x coordinate and the y coordinate. This is the x-axis and the y-axis. So we're going to start by going in the positive direction, 3, 1, 2, 3, and then we're going to go in the positive direction, which is up, 4, 1, 2, 3, 4. We're going to put a dot right on that spot, and we're going to label that spot M. The dot, however, goes right where, especially if you're working on graph paper, right where this line and this line meet. That dot has to go in the corner. For N, we're going X in the -2 direction, 1, 2, and we're going to go up or down 0, which means that point is here. We draw the point and we label it N. For point O, we're going to go positive 2 on the x-axis and -3, which is down, on the y-axis. So we're going to go positive 2 and -3, and we're going to make our spot there, and that is spot O. What I'd like you to do is push pause and do the other 4 points. Point P is at 0, so we're not going to go across at all. Positive 2, 1, 2. So this is P is found right there. Q is -5, -1. And Q is found here. R is -3, +2. R is there. S is 4, 0. So S is right here. And if I asked you what quadrant is M in, I would like you to quickly label your quadrants so you don't make a foolish mistake, because that's easy to do when you do things in your head. That's in quadrant 1. N is not in a quadrant because it's between quadrants. O is in 2, -3. This is in quadrant 4. P is also between quadrants. Q is in quadrant 3. R is in quadrant 2. And S is between quadrants. That's what that part of your homework looks like. The next part of your section talks about function boxes. And we're graphing the equation of a line by inputting different terms for our x. Now this is a word problem. This actually says that if you hire a caricature artist, you have to pay them $5 just to set up, plus $10 for every person that he draws. So our x is the number of people at the birthday party or whatever it is. So our formula is 5 plus 10x. What happens if there is only one person, or two people, or three people, or four people? They're asking us to try the numbers 1 through 4 to see how much we would have to pay our caricaturist. So we're going to put our numbers, our different numbers in for x, and x goes here. So I've written this formula 4 times, 5 plus 10 times, and here I'm going to stick in this x, and here I'm going to stick in this x, and this x, and that x. Now I actually have to do the math so I can get my y. 10 times 1 is 10, plus 5 is 15. 10 times 2 is 20, plus 5 is 25. 30 plus 5, 40 plus 5, 5. There we go. So now my ordered pair are my x's, 1, 2, 3, 4, and my y's, 15, 25, 35, 45. And now I have to graph them. So I can see very quickly that my numbers are going to go right off the charts. So I'm going to count my ups and downs as 5s instead of 1s. So I'm going to go over 1 and up 5, 10, 15. I'm going to go over 2 and up 25. Over 3 and up 35. Over 4 and up 45. And check it out. This makes a straight line. And when you draw a straight line on a coordinate plane, you extend each edge past the axes with an arrow to indicate that it's going to continue on, but you can still see the points that you plotted. This is the correct way to graph this line. This is now called a linear equation because it makes a line. And it has our x and it has our y. This that we've built here is called a function box because it helps us keep track of the answers for our equation. The next example shows a similar linear equation without the word problem part. It nicely sets up a function box for you, and it asks you to use the input numbers -1, 0, 1, and 2. So we're going to stick those in our 1 and 2 in our x's because we know what that is. Here are our x's as well. And now we get to do our math problem. 4 times -1 is -4, minus 3 is -7. 4 times 0 is 0, minus 3 is -3. 4 times 1 is 4, minus 3 is 1. 4 times 2 is 8, minus 3 is 5. So now we're going to fill in our y's, and we have our ordered pairs that we can now graph. -1, -7, doink, doink, right there. 0, -3, 1, 1, and 2, 5. And we have a straight line-ish, if I could draw. What happens when you don't have a straightforward linear equation? The next example gives us y equals 2x squared plus 1. What happens when our x is squared? It asks us to use -2 through 2 as our input numbers. And we fill them in, and then we do our math. -2 squared is 4, times 2 is 8, plus 1 is 9. -1 squared is 1, times 2 is 2, plus 1 is 3. 0 times 2 is 0, plus 1 is 1. 1 squared is 1, times 2 is 2, plus 1 is 3. 2 squared is 4, plus times 2 is 8, plus 1 is 9. So check this out. We have the same y's with different x's. So this is not going to be a linear equation. When we graph this, -2, 9, -1, 3, 0, 1, 1, 3, 2, 9. We end up with what is called a parabola. Any x squared equation, not any, but x squared equations create a parabola. At the bottom is not a point, the bottom is a curve with a point as its lowest spot. And these go up for infinity in both directions, depending on how big your x gets. What about the next example where our linear equation has a set of absolute value bars? Here we have to treat this like they're parentheses, like these are grouping symbols, and solve for x. And they asked us to solve for -5 through -1. And I don't have room for -1. So -1 is going to go out here. And we stick in our numbers. -5 plus 3 is -2. Absolute value of -2 is 2. -4 plus 3 is -1. Absolute value. -3 plus 3 is 0. -2 plus 3 is 1. -1 plus 3 is 2. So let's stick all 5 of them in here. So we have -5, -4, -3, -2, -1, 2, 1, 0, 1, 2. Now with absolute value, it does make a V shape. This is for absolute value. -5, 2, -4, 1, -3, 0, -2, 1. There we go. This does make a V shape. It has a point on the bottom. So you've just learned how to graph 3 different types of equations with x's and y's. One that's a straight linear equation, one where the x is squared, and one where the x has an absolute value. Could you please pause the video and do check it out number 4 on the bottom of this page so you can have practice with each of these problems as well. So our first problem, 1/2 x minus 4, and it asks us to use these x's that I've already stuck in this equation. 1/2 times -4 is -2 minus 4 is -6. 1/2 times -2 is -1 minus 4 is -5. 1/2 times 0 is 0 minus 4 is -4. 1/2 times 2 is 1 minus 4 is -3. 1/2 times 4 is 2 minus 4 is -2. And when we graph this, 3, 4, and 6, 2 and 5, 0 and -4, 2 and 3, 4 and 2. There's our line. And we're going to pull it all the way through both axes to show that it goes on forever. Our second problem is 3x squared plus 3. And they've asked us to use these particular numbers as our input. And I've taken these numbers and squared them and put them here. 3 times 9 is 27, plus 3 is 30. 3 plus 3 is 6. 0 plus 3 is 3. 3 plus 3 is 6. 27 plus 3 is 30. -3, -1, 0, 1, 3. When we graph these, and our last one, 3 and -30 is way the heck up here somewhere. And because this is an x squared, we know this is a parabola. So as we graph it, we're going to bring it into a curve with arrows on both sides.